Hello everyone, this is going to be a video on synthesis reactions. So synthesis reactions are the combination of two things, right? So the general form of a synthesis reaction goes as follows. A plus B yielding AB, right? And so there's some few things that you have to notice here. One, generally A and B are simple compounds, right? What does a simple compound mean? Well, these usually mean elements, etc., right? So normally we're just going to be dealing with elements. AB is going to be a combination, right? So for example, if A were a metal and B were a nonmetal, okay, if A were a metal and B were a nonmetal, well, this would form an ionic compound, wouldn't it? Because metals lose electrons, nonmetals gain electrons, right? So you would form an ionic compound here. If instead A were a nonmetal and B were a nonmetal, you would form a covalent compound. Okay? And in either case, right, what you're forming is something more complicated than the parts, right? And so synthesis reactions are very useful for a lot of simple stuff, right? So, for example, and let me actually clear the screen. Let's say we had hydrogen gas combining with oxygen gas to form something, right? To form something. Well, the way we should approach this is for elements, it's useful to approach this by looking at the ions, right? It's useful to approach this by looking at the ions. Regardless of whether it's a salt, right, a combination of a metal and a nonmetal, and regardless if it's a molecule, combination of a nonmetal and a nonmetal, regardless of what type of compound it is, for synthesis reactions, it's really useful to look at the ions. Okay? So, right, hydrogen, if you look at the periodic table, it's in group 1, right? It's in group 1. So, because it's in group 1, it forms +1 ions. So, that means we form H+. If you take a look at oxygen, it's in group 16. Okay, it's in group 16. So, being 2 away from the noble gases, you know the noble gases have 8 valence electrons. So, in order to become more like a noble gas, oxygen is going to try and gain 2 electrons. Okay, so that means oxygen forms 2 minus. Okay, so in order to balance the 2 charges out, right, you need 2 hydrogens and 1 oxygen, right? You can cross the charges. Okay, 1 oxygen, 2 hydrogens. So you form H2O. That's going to be formed as a gas, right? Don't worry too much about the states for covalent compounds. They tend to vary quite a lot. But for salts, they're always solid. Okay. So after you predict the products, then you want to balance, right? 2 hydrogens on both sides here, 2 oxygens on this side, 1 on this side. So we're going to put a 2 here. We'll rebalance. 2 hydrogens on this side, 4 on this side. So we're going to put another 2 here, and that should balance it. Okay. So this is the synthesis of water. Okay. Let's take an ionic compound, for example, right? Let's take Na, right? Sodium solid plus chlorine gas. Again, you want to take a look at the ions. Sodium forms plus ions. Chlorine forms minus ions. So when they combine together, they form NaCl. Okay, plus and minus just cancel out, so we can combine them in a 1-to-1 ratio. Right. To balance, 1 sodium, 2 on this, 2 chlorines on this side, 1 on this side. So we're going to put 2 here. Rebalance, 1 sodium here, 2 sodiums here, so we'll put a 2 there. Okay, so this is the basic structure of a synthesis reaction. There's one thing that you should know, and that's regarding these elements, right? Chlorine, hydrogen, oxygen. So we don't write this reaction as Na plus Cl, right? We always write it as Na plus Cl2. All right, so Na plus Cl is wrong, Na plus Cl2 is right. The reason being is because chlorine exists naturally as a diatomic molecule. That is, it exists as itself with 2 atoms in the molecule, right? So chlorine is one of those elements. Hydrogen is one of those elements. Oxygen is one of those elements. So, what elements naturally exist as diatomic molecules? Well, you just have to remember Hänkelbrief. Okay, Hänkelbrief, right? That should help you remember it, right? That's my little mnemonic. So Hänkel. So this H is hydrogen, of course, O is oxygen, N is nitrogen, chlorine, bromine, iodine, fluorine. Okay. All right. Take care, everyone.